Take 10 cuttings from any plant in your garden. Dip 5 in raw honey, dip 5 in nothing. Stick them all in the same pot. Same soil, same water, same light. Wait 3 weeks. Pull them out. Count the roots. The honey cuttings will have more roots, longer roots, and thicker stems. Every time. The dare costs $3. The lesson is worth every bag of rooting hormone you will never buy again. Subscribe and hit the bell. Every share helps preserve what they tried to erase. The archive opens in Egypt, 1550 BC. A medical text is written on papyrus, 20 meters long, over 700 remedies. It is now called the Ebers Papyrus, one of the oldest and most important medical documents on Earth. Among the remedies is a wound treatment, lint, animal grease, and honey, applied directly to open wounds, burns, skin ulcers, infections. The honey sealed the wound. The honey killed the pathogens. The honey promoted new tissue growth. The physicians who wrote that text did not know about bacteria. They did not know about enzymes. They did not know about hydrogen peroxide. They just knew that when you put honey on a wound, it healed faster, cleaner, and with less rot than anything else they had. The Greeks learned it from the Egyptians. Aristotle, writing between 384 and 322 BC, described pale honey as being good as a salve for sore eyes and wounds. The Romans adopted honey into their medical practice. So did the Aztecs. The Sumerians had already written about it on clay tablets between 2100 and 2000 BC. That is 4,000 years of documented cross-civilizational independent confirmation that honey heals wounds, open wounds, on skin, on tissue, on any living thing that has been cut. A plant cutting is an open wound. The bottom of every stem cutting you have ever taken is a wound. Exposed vascular tissue, severed cells leaking moisture. A raw surface vulnerable to bacteria, fungi, and rot. If infection reaches that cut before roots form, the cutting dies. If dehydration collapses the cells before roots form, the cutting dies. The number one cause of propagation failure is not genetics. It is not light. It is not temperature. It is not the absence of rooting hormone. It is rot. Bacterial and fungal infection at the wound site that kills the cutting before it has time to root. For 4,000 years, humans have known that honey prevents rot in open wounds. For 4,000 years, the solution to the number one cause of cutting failure has been sitting in a jar on the kitchen shelf. And for the last 70 years, the garden industry has sold you a $15 bottle of synthetic powder, and never once mentioned the $2 jar that does 3 things the powder cannot do at all. Here is what happens inside honey. The biochemistry has been documented since 1963. Honey contains an enzyme called glucose oxidase. This enzyme is produced by the honeybee and deposited into the honey during the ripening process. In concentrated, undiluted honey, the enzyme is dormant. The high sugar content, roughly 80%, creates an osmotic environment so hostile that most bacteria cannot survive. Their cell walls lose water through osmosis, and they die. This is the first antimicrobial mechanism, osmotic dehydration. It is also why honey never spoils. Archaeologists have found 3,000-year-old honey in Egyptian tombs that was still edible. But the second mechanism is more important. When honey is diluted, with water, with wound moisture, with the sap that leaks from a freshly cut stem, glucose oxidase activates. It converts glucose into 2 products, gluconic acid and hydrogen peroxide. The hydrogen peroxide is released slowly, continuously, at concentrations between 15 and 50 parts per million. A study published in the Journal of Alternative and Complementary Medicine found that diluting honey to concentrations between 15 and 67% led to significant hydrogen peroxide accumulation. That concentration is high enough to kill bacteria and fungi on contact, but low enough to leave living plant tissue completely unharmed. The release is not a single burst. It is a sustained, low-level, continuous sterilization field that lasts as long as residual honey remains on the surface. The third mechanism is pH. Honey is characteristically acidic, with a pH between 3.2 and 4.5. A study published in the Asian Pacific Journal of Tropical Biomedicine confirms that this pH range is low enough to be inhibitory to several bacterial pathogens. E. coli cannot grow below pH 4.3. Salmonella species cannot grow below 4.0. Pseudomonas aeruginosa cannot grow below 4.4. The honey creates an acid environment at the wound site that most plant pathogens cannot tolerate. The fourth mechanism is physical. Honey is viscous. It forms a physical barrier over the wound that seals moisture in and airborne pathogens out. It prevents desiccation of the exposed tissue while simultaneously blocking colonization by fungi and bacteria. 4 mechanisms: osmotic dehydration, hydrogen peroxide production, acidic pH inhibition, physical barrier formation, operating simultaneously, continuously, from a $2 jar of raw honey. Now here is what synthetic rooting hormone does. It delivers one compound, indole 3-butyric acid, IBA. a synthetic version of the naturally occurring plant hormone auxin, which stimulates cell division at the cut site and encourages root initiation. That is it. One compound, one function. No antimicrobial activity, no antifungal protection, no pH modulation, no physical barrier, no wound care. Garden safe take root at Home Depot. $8 for 2 ounces. Active ingredient, indole 3-butyric acid at 0.1%. That means 99.9% of the jar is inert of filler. Talcum powder. You're paying $8 for a dusting of synthetic hormone in a jar of talc. Benide Bontoni 2 at Lowe's. Similar price, similar formulation. Clonex rooting gel, $21 for 100 milliliters. Hormex rooting powder number 1, $37.47 per pound. Rhizopon AA number 3, $44.40 per pound. These are professional grade products, and they do one thing. A 1 pound jar of raw, unprocessed honey costs between $2 and $5 at any grocery store. It delivers glucose oxidase, hydrogen peroxide, gluconic acid, amino acids, trace minerals, natural sugars, antioxidant, polyphenols, and a bee-produced antimicrobial peptide called B. defensin 1 documented in a study published in the FASEB journal. 1 jar, 6 active mechanisms, $2. But the garden center sells what the garden center sells. The University of Hawaii College of Tropical Agriculture and Human Resources published a study comparing honey to synthetic rooting hormones across 5 plant species. Tip cuttings were dipped in a diluted honey solution. 2 cups of boiled water mixed with 2 tablespoons of raw honey, cooled to room temperature. Other cuttings were dipped in Hormex number 1 or Rhizopon AA number 3, industry standard commercial rooting hormones. Control cuttings received no treatment. The results? Hemagraphis alternata. Honey, 94% rooted. Synthetic hormone, 88% rooted. Honey produced heavier cuttings with more root mass, Ericus hypogaea, the peanut plant. Honey, 92% rooted with an average mass of 4.7 grams. Synthetic hormone, 78% rooted with 4.25 grams. Control, 40% rooted with 0.7 grams. Plumbago, Zeylanica. All treatments rooted at 99%, with virtually no difference between honey, hormone, and control. For ground cover species, honey matched or exceeded synthetic hormone performance in every measured parameter. The State University of New York at Canton published a separate study in the American Journal of Applied Biotechnological Research testing 6 species. Rose geranium, jade plant, Christmas cactus, China rose, English ivy, periwinkle, 3 groups per species. Raw, unpasteurized honey solution, store-bought pasteurized honey, and water control. The conclusion. Raw, unpasteurized honey served as an effective medium to promote root development in plant cuttings. The raw honey group developed roots faster, had more specimens with visible roots by the end of the experiment, gained the most mass, grew the longest roots, and experienced little to no necrosis. The pasteurized honey group showed necrosis in some specimens and no root development in others. The control group had the most necrosis and the least root development. The key finding. It was raw honey that worked. Not processed, not pasteurized, raw. Because pasteurization destroys glucose oxidase. Without glucose oxidase, there's no hydrogen peroxide production. Without hydrogen peroxide, there's no sustained antimicrobial protection. Without antimicrobial protection, the cutting rots. This is why the type of honey matters. This is why the $2 jar of raw, unprocessed honey from a local beekeeper or the health food aisle does what the pasteurized squeeze bear on the breakfast table does not. In 2025, researchers from Mississippi State University, the University of Arkansas, the University of California, Riverside, and the USDA Agricultural Research Service published a study evaluating honey as a rooting adjuvant for 3 common nursery crops: rose, camellia, southern magnolia. They tested multiflora honey, manuka honey, locally sourced honey, and no honey controls, all combined with varying rates of synthetic IBA. The findings. For southern magnolia, one of the most difficult to root species in the nursery trade, multiflora honey improved both root number and root quality, outperforming every other treatment, including synthetic auxin alone. Cuttings treated with multiflora honey had higher root quality ratings compared to cuttings treated with no honey. For rose, combining manuka honey with 500 parts per million IBA produced greater root length and shoot height than IBA alone. The researchers noted that honey's antimicrobial effects may positively impact the rooting of species susceptible to pathogens during propagation. The nursery industry in the United States reported $18.3 billion in sales in 2024. Propagation accounts for over 50% of annual labor budgets at some operations. Labor represented $4.8 billion of the industry's $11.6 billion in expenditures. A jar of grocery store multiflora honey improved root quality on a species that routinely fails at commercial scale. The study was published. The data is public. And the garden center shelf still has a $15 jar of talcum powder with 0.1% IBA in the featured display. Scott's Miracle-Gro, the leading marketer of branded consumer lawn and garden products in North America, reported approximately $3.4 billion in sales. They hold an estimated 50% share of the United States consumer lawn and garden market. Their products occupy dominant shelf space at Home Depot, Lowe's, and Walmart. Their business model depends on the consumer purchasing branded, packaged, factory-produced solutions for every garden problem. A $2 jar of raw honey that outperforms their rooting product does not fit that shelf. Here's what you do. Go to any grocery store. Buy a jar of raw, unprocessed, unpasteurized honey. The label must say raw. If it says pure but does not say raw, it may be pasteurized. Pasteurization kills glucose oxidase. The enzyme is the mechanism. Without it, the honey is sugar syrup. Raw honey from a local beekeeper is ideal. Raw multiflora honey from the health food aisle works. The cost will be between $2 and $5. One jar is enough for hundreds of cuttings. Boil 2 cups of water. Stir in 2 tablespoons of raw honey until dissolved. Let the solution cool to room temperature. Do not use it hot. Heat destroys the enzyme. This is the recipe published in the University of Hawaii study. It costs roughly 11 cents per batch. Take your cutting. A stem cutting 4 to 6 inches. Cut just below a node with clean, sharp shears. Remove the bottom leaves, leaving 2 to 4 leaves at the top. Dip the cut end into the cooled honey solution. Submerge the bottom inch for 30 seconds. The honey coats the wound. The glucose oxidase is now in contact with the moisture on the cut surface. Hydrogen peroxide production begins immediately. Stick the cutting into moist propagation medium. Perlite and vermiculite at a 3-to-1 ratio is what the Hawaii study used. Potting mix works. Even moist garden soil works for easy rooting species. Place in indirect light. Keep the medium moist, but not waterlogged. Do not cover with plastic if using honey. The antimicrobial protection reduces the risk of the fungal growth that sealed humidity domes can encourage. For a stronger application, dip the cut end directly into raw honey, not diluted. The concentrated honey creates a thicker seal, stronger osmotic barrier, and more sustained antimicrobial protection. The SUNY Canton study noted that dipping cuttings directly in raw honey and keeping them in a moist environment could be an even more effective approach. Within 1 to 3 weeks for ground cover and herbaceous species, you will see roots. Within 6 to 11 weeks for woody species. The cuttings treated with honey will show less necrosis, more root initiation points, greater root mass, and healthier stem tissue than untreated cuttings. No mixing with talc, no measuring parts per million, no expiration dates, no warning labels, no latex gloves, no eye protection advisory printed on the back of a $15 jar. Raw honey, $2, aisle 7. The Eber's papyrus is 3,500 years old. The wound healing mechanism it described has now been documented in over 1,000 peer-reviewed studies. Glucose oxidase was identified in 1963. The hydrogen peroxide pathway was confirmed the same year. The antimicrobial peptide B, defensin 1, was identified in 2010. The pH mechanism, the osmotic mechanism, the physical barrier mechanism, all documented, all published, all available in the public literature. Every jar of rooting hormone on the garden center shelf contains 0.1% active ingredient and 99.9% filler. The jar costs $8 to $44. It does one thing, delivers a synthetic hormone. It does not protect the wound. It does not kill pathogens. It does not prevent rot. It does not seal moisture. It does the one thing that the cutting's own natural auxin was already doing on its own, just slightly faster. Honey does 3 things the powder cannot do at all. It seals, it sterilizes, it feeds, and it costs $2. The Egyptians wrote it down 3,500 years ago. The bees have been making it for 50 million years. The science has been published for 60 years. The dare costs $3, 10 cuttings, 5 dipped, 5 not. Same pot, 3 weeks. Count the roots. The Garden Center hopes you never try. If this story opens something for you, subscribe to DTD Stories and hit the bell. Every like and every share preserves what they tried to erase. The next story opens soon.